Welcome to this module. In this session, we are going to talk about temperature targets and carbon budgets, a concept which has emerged strongly in the scientific, political, and business domains. As we have seen, the economy is heading towards 5 degrees warming, current policies to 4 degrees, INDCs to around 2.7. The political consensus aims at well below 2 degrees, and most likely to provide the safest level to our children, we should aim at 1.5. What do these temperature targets mean? What are their practical implications? One of the key breakthroughs in climate science has been the linking of temperature targets to cumulative CO2 emissions. This is best illustrated by a famous graphic in IPCC's 5th assessment report. This graphic shows that, despite the complexity of the climate system, there is a linear relationship between cumulative CO2 emissions and global average temperature increase. It is based on this knowledge that carbon budgets are built. A carbon budget is the cumulative amount of carbon dioxide emissions we can emit over a period of time to keep Earth from warming below a certain temperature threshold and with a certain probability of success. However, the science of carbon budgets keeps evolving, and carbon budgets themselves depend on variables that can vary from study to study, such as the climate model used, the definition of global average temperature, global surface air temperature, or global mean surface temperature, and if they are based on projected temperatures increases or on the observed levels of warming. But despite uncertainties, carbon budgets are extremely useful because they are a concrete expression of Earth's limits to cope with the consequences of human activity. Contrary to our financial budgets, the carbon budget is not renewed annually or even every 10 years. Its validity is, at human timescale, perpetual. The only way we can put more CO2 into the atmosphere without suffering the consequences is if we take the same amount from the atmosphere, a concept known as net zero emissions, or if we capture more CO2 than what we emit, which is known as negative emissions. Knowing that we have a finite amount of CO2, scientists have thus made the question: how can we go from the current levels that we put into the atmosphere annually all the way down to net zero? And when do we need to be at zero? The answer to these questions are greenhouse gas mitigation scenarios that distribute the carbon budgets into the future in order to respect the carbon budget constraint. The many scenarios produced have been studied and compiled by the IPCC, and the results show that if we want to stay well below 2 degrees, or around 1.75, we need to halve emissions by around 2035 and get to net zero by 2050. We can express it in terms of the time we have left under the current levels. If nothing is done, we will exceed the allowed carbon budget to stay within 2 degrees within approximately 15 to 20 years. Scenarios are the result of complex modeling of the economy, which takes in consideration the role different economic sectors play, available technologies and their greenhouse gas mitigation potential and cost, as well as emerging technologies that can help reduce emissions. They can also take in consideration behavior and social attitudes changes. For example, what if everyone decided to be a vegetarian? Or what would happen under increased deployment and use of public transportation systems in all major cities? By using this type of modeling, one can go from a global carbon budget to a sectoral carbon budget. Note, however, that the decision of how to apportion the carbon budget to different sectors or countries is not neutral. There are important equity and economic implications which are subject to intense political debate. One of such scenarios that distributes the global carbon budget is the International Energy Agency, or IEA, Energy Technology Perspective Scenario, which have been used in ACT methodologies. We use it to plug it on a methodology developed by the Science Based Targets initiative, the so-called Sectoral Decarbonisation Approach, or SDA. With the SDA, one can compare a company greenhouse gas emission reduction target with a global sector or country sector specific scenario or pathway that is in line with a 2-degree or a 1.5 goal. We use this tool to calculate indicators on the ambition companies demonstrate to reach the net zero goal. You will hear more on this type of indicators further ahead. To date, 13 sectors are covered by the IEA, with a focus on direct emissions and indirect emissions from energy use. Despite the great advantages of the SDA science-based target methodology, it does not provide answers to all our needs, particularly for indirect emission target setting. But there is continuous work to improve the existing tools. To finish, a recap of what we have seen in this module. Scientists tell us that we have limited amounts of CO2 that can accumulate in the atmosphere if Earth's global average temperature increase is to stay below 2 degrees. Politicians have set an ambition in the Paris Agreement to get to well below 2 degrees, aiming to reach 1.5. From these temperature targets, global carbon budgets can be derived. The carbon budgets are distributed in time using integrated assessment models that build possible greenhouse gas mitigation scenarios or pathways for the whole economy to go down to net zero emissions or negative emissions. These pathways can be further break down into country and sector-specific pathways. By using the Sectoral Decarbonisation Approach, one can derive a greenhouse gas pathway for an individual company that is compatible with the original scenario. And with this, we can create proper accountability to check if companies are aligning themselves with the necessary low-carbon transition. This is what the next sessions will cover. Looking forward to see you there.